Olá pessoal, boa tarde. Estamos ao vivo na plataforma de webinars do Embarcados para mais um webinar aí com bastante conhecimento sobre desenvolvimento de projetos em sistemas eletrônicos, sistemas embarcados, para vocês que trabalham com IoT, né? Todo mundo que desenvolve produto, a gente sempre traz aí bastante conteúdo para vocês, né, que auxiliam os engenheiros desenvolvedores no seu dia a dia. Hoje nós vamos ter aqui um webinar com o pessoal da Irose, desenvolvendo a próxima geração de produtos, conectores que definem o futuro da tecnologia. Antes de apresentar as pessoas que estarão aqui com a gente, né, estamos ao vivo agora aqui, nós gostaríamos de pedir para vocês deixarem aí, né, de onde vocês estão falando, que empresa vocês estão falando, deixar o LinkedIn, fazer conexões, deixar perguntas aí para os especialistas, que nós vamos ter, além do webinar, depois também uma sessão de perguntas e respostas bem legal aqui, né, com os especialistas. Receberemos hoje Jorge Jimenez, que é especialista sênior em programas de marketing da Irose, o Dave Gallagher, que é diretor de treinamento corporativo da Irose, o Mark Warren, que é gerente de contas estratégicas da Irose, e o Zili Lang, que é engenheiro eletricista, engenheiro de aplicações, FAE, especialista em alta velocidade, então para conectores bem específicos, se vocês demandam alta velocidade aí no projeto de hardware de vocês, tá bom? O webinar de hoje, né, nós vamos explorar os conectores inovadores da Irose e como eles possibilitam a geração, né, que vem por aí, né, de novos produtos inteligentes. Eles vão trazer exemplos do mundo real e soluções de ponta que enfrentam os desafios de projetos atuais quando preparam o cenário para a tecnologia de amanhã. Então, pensando nos novos produtos, pessoal. Então, o que vocês vão aprender nesse webinar, né? Durante esse webinar, eles cobrirão os seguintes tópicos: restrição de formato, form factor, gestão de energia e integridade de sinais, e também as características inovadoras aí dos mais novos conectores que eles têm nessas linhas e famílias que eles estão lançando, tá bom? Então, vamos lá. Vamos começar o webinar agora. E nós vamos chamar, então, para a sala, para começar, Rogério Moreira, que é da ATL. Ele vai fazer uma apresentação aqui em português, breve. Depois a gente chama os especialistas lá dos Estados Unidos. Tudo bom, Rogério?
Tudo bem, Tiago. Obrigado aí a presença de todos, a atenção nesse webinar. Eu sou Rogério Moreira, trabalho na ATL. A ATL é uma empresa de representação comercial na área de componentes eletrônicos, né? Nós atuamos em toda a América Latina, México, Brasil, Argentina, Colômbia. No caso específico da Hirose, nós representamos a Hirose na América do Sul, né? Aqui, principalmente aqui no Brasil e Argentina. A Hirose é uma empresa fantástica, fabricante de conectores de alta tecnologia, conectores de alta qualidade também. Ela é uma empresa que já tem 87 anos, foi fundada no Japão em 1937. Então, é uma empresa com muita experiência acumulada no setor de conectores, né? Tem várias fábricas distribuídas pela Ásia, né? Fábricas no Japão, na Coreia do Sul, na Indonésia, na Malásia, na China, né? E tem diversos tipos de conectores, né? Conectores para I/O, conectores padronizados, USB, tipo D, Ethernet, SIM card, SD card, né? Tem diversos conectores placa a placa. E um ponto importante, ela é muito forte na área de conectores flexíveis, né? Conectores ZIF, Zero In Force, né? Os famosos FPC, FFC. Se você não quer ter problema no seu display ou no seu circuito flexível, a Hirose tem muitas opções disponíveis, né? Também tem conectores de RF coaxial, o famoso UFL, foi projetado pela Hirose em 1991. Ela é que projetou o conector UFL, que hoje é largamente utilizado, né? Tem conectores para fibra ótica, para área automotiva, conectores de alta corrente, né? 100, 200, 300 amperes, né? Conectores de high speed, né? Grande capacidade de comunicação, alta velocidade de comunicação, que nós vamos ver aqui nesta apresentação, né? E também conectores à prova d'água, né? IP67, 68, circulares, né? Então, tem um portfólio de produtos excelentes. Eu convido você, então, a entrar depois desse webinar no hirose.com e ver todos os conectores que vão se adequar ao seu projeto, né? Nós, como representantes, coordenamos a distribuição. Então, a Hirose tem uma linha, uma rede de distribuição aqui na América Latina, formada por grandes distribuidores, como a Avnet, a Future, a Highland, né, são os nossos distribuidores globais. Né? Temos distribuidores locais também, como a Alphatec e a Outcomp. Né? E também trabalhamos com os principais distribuidores de catálogo, a Mauser, a DigiKey, a Newark, que aqui no Brasil é representada pela Lateri. Né? Então, existe aí uma ampla rede de distribuição, de canais de acesso para você utilizar os conectores da Hirose. Então, mais uma vez, eu agradeço a sua atenção, estamos à disposição para prestar qualquer informação da Hirose para vocês. Okay? Muito agradecido. Vamos agora voltar ao Tiago.
Muito obrigado, Rogério. Obrigado pela introdução. A gente volta então contigo e com o pessoal aí da Hirose depois no final para as perguntas e respostas, pessoal. Obrigado a todos que estão conectados. Deixem então comentários e perguntas no chat, tá? Estamos ao vivo aqui, tá? Então a gente vai rolar depois a sessão de perguntas e respostas. Agora, pessoal, nós vamos conectar com os profissionais da Hirose lá dos Estados Unidos para começar esse webinar aí para vocês. Vamos nessa.
Good afternoon. Thanks for joining us. Today's topic is innovation. Innovation creates wealth for societies, companies, and individuals. We're going to focus to innovation about product development and how to make your product smarter. You make your product smarter by adding new features, combining new technology, and adding more components, sometimes from different companies. The challenges that engineers face across industries are very similar. Higher speed, more data, higher vibration, combining multiple boards, reliability, tolerance stack-up, and so on. Today we have three presenters from Hirose America. Dave Gallagher, our corporate training director, is a connector expert with a patent and published articles, bringing over 30 years of experience in electronics, cables, and connectivity.
Thanks for having me today.
Mark Warren, Senior Technical Marketing Specialist based in San Jose, California, supports Hirose's RF, 5G, and consumer electronic solutions. With over 20 years in Silicon Valley, he brings extensive technology and business experience.
Happy to be here.
Finally, Zili Yang, Electrical Engineering and High-Speed Field Applications Engineer, based in San Jose, California, specializes in Hirose's high-speed connectors up to 112 gigabits per second, ensuring top performance for advanced applications.
Thank you for introducing me.
Thanks, Dave, for joining us. More and more customers are trying to put more data at higher speed. Can you share an experience you have to help customers solve these challenges?
Yeah, absolutely. So we work with a lot of customers, and one in particular I was thinking about was a customer in the consumer electronics industry. They build a small office, home office type router and wireless equipment, and they had some challenges. We look at those devices. They have a small industrial design. They have tight spaces, lots of heat to deal with inside that tight space. A lot of connectivity issues there. And in this particular case, they were trying to connect a couple of boards together on the inside of their box. And the tight space meant that they had to get power, they had to get data between these two boards. They were using two different connection options before, and now they needed to combine that down or make that easier for them to do and reduce the amount of resistance to airflow inside the box. So really tight space. So in the application we worked with them, we were looking at our FX23 series, which is a floating board-to-board connector, and it offers the height range they needed was between 20 and 25 millimeters, so that was perfect for their application. the hybrid power and data in that situation. So we were delivering 3 amps per contact power, 4 contacts on the inside of that design. That was a big benefit for them, and it supported the data speeds they were needing, which was PCIe 3.0, looking at 8 gigabit speeds.
So you mentioned floating connector. Why was this feature important for this application?
So floating, most folks initially think of floating, I say most, right? It's relatively new technology, but floating connectors offer absorption of alignment between a couple of connectors. So if you have more than one board-to-board connector, floating will absorb the tolerance between those 2 different connectors inside that board. Now in this particular case, the customer was actually only using one board-to-board connector. And floating wouldn't necessarily benefit them in that situation, but for them, we're talking about a product that's built in high volume and tight spaces. The boards are mounted on the shell. There's not a lot of control of positioning as much, so that floating allowed some misalignment. And if they didn't have that, if there was a misalignment as they tried to press the boards together, they could potentially damage the connector or damage the board. And that allows them to absorb it, makes the manufacturing process easier.
Yeah, I see that the floating feature helps in 3 aspects. 1, during the design to help with tolerance stack up. 2, during the assembly for misalignment. And 3, during the operation to make it more reliable contacts, especially, for example, for vibration. You also talk about PCIe 3.0, around 8 gigabits. What speeds were the customers using before?
So before they were sub gigabit speeds. So they were running PCIe 1.0 type speeds. But with you look at all these devices you have in your household these days, everything connects to the internet. So they needed more data bandwidth on the system internally. So they needed 5 gig is what they really needed. But the FX23 series gives them a little bit of headroom. So at 8 gig capability on that connector or higher, that connector offered that headroom that they needed for future growth.
Why was our FX23 great for this application? What made it stand out?
So there was a couple of features in there. Obviously, floating we already talked about a little bit, and we talked about the data speed. But the other thing that I didn't really highlight too much is that hybrid power and data combination. These days there are a lot of connectivity, lots of power demand in these devices. So having those power contacts was really a big advantage. So now that you went from 2 connections down to 1 connector between the boards, that just saves money ultimately because of fewer connectors. Makes the assembly process easier. Easier means less time. Less time equals less cost. So that's a big advantage for a customer.
Thanks, Dave. Mark, we hear about challenge for a customer about higher speed, combining signal and power. Did you run into a similar case where you have to help a customer with these challenges?
Oh, absolutely. Maybe a fairly recent good example that I want to share is a customer doing a small medium handheld point of sale device that had a whole lot of electronics packed inside a small form factor, including high frequency processors, high resolution display, high resolution touch panel, and multiple high frequency radios in there for communication purposes. So amongst other challenges, 2 primary challenges they needed help finding solutions for involved a very small form factor with a variety of pin counts, but also something that was going to help them mitigate the EMI concerns that were a result of all of these noisy elements, that I just described inside a small package in close proximity to each other. So we steered them, and they were very happy to find a brand new product of ours introduced within the last 6 months, the BK35, which is a micro miniature connector that has integrated metal shielding built into the plastic structures of both halves of the mating connector itself.
Yeah, tell me more about this integrated shielding and how it benefits for both radiating emissions and also to protect for immunity.
I'd say starting a few years ago, during the emergence of 5G in many products, and even a little more recently, the emergence of high-frequency domain 5G radios in a lot of products, consumer products in particular for my interest, we've recognized, and some of our lead customers then were recognizing the need for doing the same EMI mitigation. So what we're on today is about our 5th generation of a integrated shield. And by integrated shield, the analogy I like to use that a lot of engineers can relate to is a shield box structure. And you've probably all seen pictures of PCB boards with aluminized metal boxes that are literally soldered around elements of components that have high frequency noise that they want to shield from other parts. So what we've tried to do, I like to say, is to emulate having a shield box actually tooled into, in our case, insert molded right into the plastic housing of these little tiny connectors. So it's a seamless 360-degree metal shield. There's one on both halves of the connector, so combined you sort of get a nested double shield effect, if you will. And just to highlight the scale that I'm talking about, which was this customer's other big challenge, I'm talking about something that's probably an order of magnitude smaller than the FX23 that Dave was just talking about. We're talking about connectors whose total stack height, when they're mated, can be as small as 0.5 millimeter in total height. So 3 mated pairs could stack up within the thickness of a penny, just to put it in perspective. So that's what I mean by integrated shield. So we've got an integrated shield in the BK35 that addresses this issue. In addition, it addresses, the BK35 addresses another issue that is also some analogous to what Dave was talking about, and that is this customer needed the ability to route power over the same path. They didn't have room to put additional connectors into their form factor. So what we've been doing also, and it's included in this product I just talked about, is adding some really beefy power rails, relatively speaking, beefy power rails at the ends of both of the connector. In this case, the BK35 has 4 of them. They each handle 2.5 amps, so together you could have a 5 amp forward and a 5 amp return, which is a lot of power for a small handheld device, and gave this customer plenty of margin to route power as well as their high frequency signaling.
It's impressive how we can put all these features in such a miniature, very small component. So what speeds was the customer using?
One of the protocols that was pushing the frequency was MIPI, which is a very popular protocol, signaling protocol that engineers choose to route to both sensors, imaging sensors, and to cameras. In this case, they were using it to route to their high resolution display. So MIPI would be one of those high frequency examples in this case that was being used.
What other challenges did the customer have to face in this product?
Right. Well, I want to throw in a comment about 2 additional factors that affect both this customer, but a lot of similar customers that are doing those same types of products. And one would be the fact that, well, we like to tout, and we're really on the bleeding edge of micro-miniaturization, as I just pointed out. And for a lot of customers, the smaller the better, period. So they want us to go even smaller. But many customers, and together, we as a supplier are recognizing today that it's not always all about having the very smallest form factor, but also having some variation in some of those dimensions. And one of the key variations that we are recognizing is important is the Z height. You might imagine one example would be that you have multiple cables being routed inside the product, sensors and cameras and touch screens. If you have multiple cables that are all stacked up at the exact same height, well, it's easy to imagine they're going to interfere with each other when you try to actually route those. So having some options on the height of even these smallest connectors gives them another degree of freedom, the engineers in the Z direction, as they're trying to route all of these signal paths together. So that's one. And I just throw in another little sort of piece of education for people who aren't so involved in the connector world like we are. We talk about a lot of our types of connectors as board-to-board connectors, right? But certainly in the small domain in particular, the majority of our customers are going to end up using those as a board to FPC, meaning one half of the connector is surface mount soldered to a rigid PCB, but the other piece of the connector is solder mounted to a FPC, which is a little flexible cable. That's going to go on to the rigid PC board. Now, there are cases where even the small form factor products are doing a hard board-to-board connection, maybe a small daughter board that might have some radio circuitry on it or a display or a sensor. In that case, they're running into the same types of alignment concerns that Dave talked about. So we've actually introduced in the last 12 months a couple new families of these tiny micro miniature products that actually sort of amazingly have these same spring-loaded X and Y shock mitigation or misalignment mitigation structures built into them. So we're really trying to cross over and recognize that some of these same issues that different customers have need to be addressed at many different form factors. So those are a couple examples.
Thanks, Mark. So in the first two cases, we hear some common challenges. Smaller space, signal integrity, combining signal and power, and the ranges of speed here were the 5 to 8 gigabits. But what if the customers has to deal with much higher frequencies? And we're talking about speeds in the 56 gigabits or higher. Zili, can you tell us an example where you help a customer solve this problem?
Certainly. So one of our customers in telecommunications, they needed a very reliable, high speed, so 56 gigabits as you mentioned, board-to-board connector. And in telecommunications, the design cycles range from 3 to 5 years compared to a standard maybe like 1 year design cycle for consumer electronics. And over the course of those 3 to 5 years, technologies can change very quickly. New technologies can be introduced, and also sometimes our customers' needs change within those 3 to 5 years. So they need some flexibility in the design. So in this case, we proposed the IT8, which has all these features that can help meet their demands.
So you talk about long design cycles, and as you are saying, in a long design cycle, things change. The packaging structure can change, the form factor, new technology, speeds. How does this series help the customers during those changes?
Yeah, so the IT series has the 3-piece design, which means there's 3 pieces to the connector, and this allows a lot of flexibility and able to change your stacking board-to-board height. So in this specific case, our customer, when they first designed this IT8 in, they're looking at 25 millimeter stack height. But as the design moved along, they had to change it to 24 millimeter stack height. And so you're able to easily achieve this just by changing some of the part numbers of the plug and the interposer. So you change the plugs from 0H plugs to 1H plugs, and the interposer from 25H interposers to 22H interposers. And to get the stacking height, you just add all the sum of the numbers, and that's the 24 millimeter stacking height that they're looking for. And so we also realized that the changing from stack height, the SI performance, the signal integrity performance is very important. So the IT8 series covers from stack heights of 14 millimeters to 46 millimeters. And typically when you go to taller stack heights, the signal integrity performance gets worse. But the IT8 series, it's so well designed that there's so much margin that even if you're going from the lowest stack height of 14 millimeters to 46 millimeters, you still get a very good signal integrity performance. Additionally, 3-piece design we found has other benefits. So one of the things is that the interposer doesn't go through reflow. So that means that piece doesn't have to absorb heat that the solder and joints need. So that reduces the amount of issues you might have with soldering. And additionally, with the assembly process, you could just put the interposer onto the M side plug, then the D side plug with the daughter port onto the interposer. You screw in the holes for these spacers, and that's it. That's the assembly process. It's a very straightforward and easy process.
Yeah, staying on this assembly process topic, these connectors have a lot of pin counts. How about the weight? How do they deal with that in manufacturing?
Yeah, so one of the things with the IT series is the high pin counts. So we're talking about 288 pins, and sometimes our customers require even 2 of these, so 500 plus pin counts. And so because of these high pin counts, they have very thick and heavy PCB boards where they have to put components on both the top side and the back side of the board. So when you're going through a second reflow where some components are on the back side, if it's too heavy, with the weight, sometimes the parts might end up falling off and causing even more assembly issues. So because the interposer, you have an extra piece that doesn't go through the reflow, doesn't go through a second reflow, there's very little chance of that actually the part falling off and that happening. And we actually seen some of our competitors that that have the traditional 2-piece design as opposed to the 3-piece design. This actually happened where the component is going through reflow and it falls off during the reflow process, and that causes even worse assembly issues. They have to reflow again. It's just a headache. And the 3-piece design helps with that issue.
So the journey for using a new product is not just the design, the connector selection, it's also addressing other issues that come along, like manufacturing. So we offer design guidelines, correct, and manufacturing guidelines to help customers?
Yeah, so the IT series provides design guidelines, which includes things like routing and how to best place the connector, and even like example cases of how you might use a connector so that our customers can use it as reference, because for the signal, it's not just going through the connector, right? It's going through the PCB, it's going through maybe some cabling as well. So you consider the entire channel, and the design guideline actually has recommendations for some of the traces and the vias and all that stuff too. On top of that, not just for the designing part, but for our contract manufacturers who was actually putting the things together, we have assembly guidelines. So it details out, the instruction process I just talked about with the screws and how to best mate it, but also very commonly asked questions. So for example, what kind of recommended, solder paste might end up using, what kind of stencil thickness, that sort of thing, to also best help the contract manufacturers not have any issues on that side as well.
Yeah. So this three-piece scheme for connector solution helps a lot with the design and manufacturing. Tell us a little more about other high-speed connectors in our products.
Yeah, so I focused mostly on the IT8 when I was talking about this, but we also have some lower speed connectors that have the same three-piece design. So an IT3, which supports up to 10 gigabits per second, and the IT5, which supports up to 25 gigabits per second. And our next generation of the IT8 series is called the IT16. That can support up to 112 gigabits per second. So, very, very cutting edge of speeds. And all these three, IT3, IT5, IT8, IT16, all have this same three-piece design. So, this has the same familiarity as our customers who have been using previous generations, easily change to higher speeds, as well as, has that same benefits as well of all the manufacturing and assembly benefits.
So this customer was using a 56 gigabit, yet we're already working on the 112 gigabit solution for future needs, correct?
Yeah, so we found that customers, they plan and design that with the next generation in mind, right? So as soon as they use 56, they're asking, okay, when is the 112 gigs coming out, and so we work with them, ask them, okay, what are your requirements? What kind of protocol are you looking at? 112 gigs PAM4, and so we use that to help design the next generation as well.
Yeah, because we're a forward-looking company. We try to anticipate customer needs. So when they get there, we are there also with our products. So Dave, we hear, although different industries, different products, we hear a lot of common challenges. What commonalities have you found in hearing these three cases?
I was just thinking, as you was talking about design guides, and my customer that I was working with, we actually contacted our team members on the high-speed team to help our customer do some of the evaluation of the board layout and design to help them get the speed performance where they needed it to be, especially considering all the challenges in their electrical design. Commonality, Mark's stuff is really cool, the small stuff and connectors, but the speed's there. The video systems, the high speed, the RF, we got RF signals in our router devices, wireless devices. All that is common. We're seeing consumer electronics and high-speed backplanes all combined together, and even in industrial markets, there's lots of commonality.
So all these challenges mean there's changes in the market. Can you give an example of how Hirose is adapting to these changes?
Yeah, well, it's funny. It's a constant thing for us because we go out and we visit the customers, and we have to listen to them and understand where their applications are going. We have to see if they're asking for 56 gig today, what are they going to be asking for next? If they need 0.6 millimeter, well, are they going to be looking for 0.5? Do we need to develop that? And where those challenges? We ask the customer that type of stuff when we're working with them, and we see that size getting smaller, the pitch getting tinier. I see that all the time in the applications that we're coming across that desk on a routine basis. Hirose has to look at this and figure out where the market's going, where are they going in the future. Because our customers don't always, Mark, I think you mentioned it, our customers don't always know what the latest technology is in the connectors. Mm-hmm. And this is absolutely an area that we have to teach them so they don't have to waste their time trying to figure it out. We try to figure it out for them in advance, and that's a big plus for us.
Yeah, Mark, in your case, you talk about handheld devices. Mm-hmm. That's not just used for consumer electronics. That could be used in industrial or medical applications. Can you tell us about other products for our consumer electronic groups that serve these other markets?
Yeah, I mentioned some other features in our board-to-board or board-to-FPC type products, such as the variable heights and the active floating capabilities. Just throw in one more mention of those quickly. We also actually have some active locking connectors. Retention force is a big area that comes up with some customers too, who might again be in an environment where their product is going to be under some shock or vibration. And in some of these cases, the smaller connectors, they're low mass. It doesn't take a lot of force for them to come apart. So we actually have some options available that actually have, I call it a deadbolt lock. It's literally a sliding lock with multiple metal deadbolt, little micro miniature, but little deadbolt hooks that are really going to keep it together. You're going to tear the surface mount solder off the PC board before the connector is going to come apart. But anyways, that was just one other mention. Another large family of products and connectors that again cross the board for a lot of different applications are a family called ZIF, which is zero insertion force. These are a one-piece connector solution. Instead of two mated pairs, it's a single piece that's soldered onto a PCB board, and the naked end of an FPC cable simply slides or is inserted into those. A typical ZIF connector would always include some sort of lever or latch that's manually activated, meaning it needs to be held open until the cable is manually inserted and then manually closed with the cable inserted in the proper orientation. We've started to build out a whole bunch of variety in our ZIF solutions, including ZIF products that support shielded FPC or FFC cables. In my world, going down to those same tiny dimensions of ZIF connectors that are sub-millimeter down to 0.6 and 0.5 millimeters in total height. And a large family of products that has been pretty well received and we're growing out very rapidly is one we call our One Action family. One Action is, I think we should call it auto locking, because that's really what it does, is instead of all these little manual motions of actuators I just described, the connector doesn't need to be touched at all. The assembler or the assembly operation just consists of inserting the end of the FPC cable. Bang, you've got some spring-loaded locking tabs that automatically seal that in place. You get some visual cues that are easy to visually, through automated vision or through manual inspection, quickly determine that it's properly seated. And on top of that, you get a nice tactical click sensation only when it's properly inserted. So again, that's our One Action family of products. It's really growing very rapidly to spread across a lot of our ZIF solutions.
Yeah, I understand also the One Action has some advantages in shipping, correct?
It's actually got, I describe it as having a threefold types of significant advantages. First one I start with is a design advantage. Again, going back to that same access, the motion of a typical ZIF connector also requires that the product is designed to maintain the mechanical or physical access point for an assembler to reach in and do that locking mechanism. That actually is sort of presents a keep out area that a designer has to keep in mind. They can't put another board right on top of the connector necessarily. They can't put tall componentry around the near in proximity of the connector, because that space has to be kept free for the actual locking mechanism. That all goes away in the One Action. So all you do is slide the cable in. You can now have a much tighter design or a relaxation of those constraints around it. So a design advantage is one. There's a logistics advantage. Typical or legacy ZIF connectors also most frequently need to be from the factory to the final assembly process shipped and maintained with that actuator lever I talked about held in an open position, because closing those levers without a cable in place, especially for the micro types of solutions, can actually deform those tiny little metal contacts inside and degrade the operation somewhat. So that's a second advantage. And the third and most obvious one maybe is that advantage of assembly time. We've done our own quick studies and easily shown that we've got a multi-fold decrease in the amount of assembly time required for each process versus the insertion, closing of the lock type of actuator.
Yeah, and the advantage in assembly is not only the time, it's also the training. You don't need to train people you have to open the lever to the back, to the front, what that actuator it is. They just have to press it in, easy to do.
Yeah.
So all these connectors are used in many industries. Today we talk about 3 cases that cover the industries, but we are not limited to that just those 3. our challenges are very similar across industry. And our connectors also can be used in medical and automotive. Dave, can you measure some examples of how we fit in the automotive and medical industry?
Sure. Yeah, no, we definitely, it's funny, all these products, you look around the industry, we're interacting with data and technology at all levels. You mentioned automotive. Your car today, there's infotainment systems, there's driver assist systems. Those driver assist systems have cameras built in that look out in front of the car or behind the car. Your backup cam, right? Those are using those micro connectors that Mark was talking about. But at the end of the day, there's a heart inside of a computer that's running all that data that's pumping, multi-gigabits on the inside. So that's your car today. It's a rolling computer system. Medical world, ultrasound systems. I mean, you show up the hospital now, your ultrasound used to be on a big cart. Now it's a tablet and a simple handheld probe. You got infusion pumps, you got all kinds of MRI, CT scan systems. Those are bigger, they might have bigger connectors or bigger interfaces. And then you look at the tablet type devices, there's a small handheld, even wearables market, medical wearables today, glucose monitors, other type of devices. They're everywhere and they're tracking data, monitoring information. Sometimes a patient can get their data tracked while they're at home and they don't have to sit in a lab for 3 hours while some doctor evaluates data. They put a monitor on their body, they go home, and they come back the next day, and the doctor can read all that data off that monitoring device and understand what's going on with that patient in a real-world environment.
Yeah, the medical industry is fascinating. You go from wearables, hearing aids, all the way to large machines and cover everything in between. So far, in your case, we were talking about PCIe 3.0, which is 5 to 8 gigabits. In Mark's case, we're talking about MIPI around the same similar range, in really higher speeds. The common denominator is all the customers, when they go through a new product development, they more than double their speed typically. So it's not just the connector that has to handle speed, it's how you go in the journey to do the design. So really, besides offering these high-speed connectors, how else can we help the customer?
Yeah, so alongside the high-speed team in Hirose, we also have the signal integrity team, and there's experts in there that help with verifying the customer's design. So if a customer is saying they'll use this connector for this channel, we can actually verify it for them. In addition, they also provide things like the simulation models and full reports that shows how well the connector performs in those speeds. So one of the things we see with our competitors is that they say connector can support that speed, and it can, but then the margin for those is not as good. And so you have to consider the entire channel, because your signal's not just going through connectors, going through like the PCB, the VS, and all of that stuff too. So our signal integrity team, they can provide some recommendations and verify that in your entire channel along with the connector, it can support those speeds as well. And another thing too is we actually provide something called loaner boards with these connectors mounted on them. And we loan these out to our customers so that they can take measurements themselves and verify, the simulation and also the measurements are very similar. So you can, see that the performance is exactly what we say it is. And, you won't have issues with later on where customers may design our competitors in, and then they actually finally run the channel in and then see that it's failing. They won't have that issue with our SI team helping them.
And we offer these services not only for people in the 56 gigabit per second. We also offer these services for our industrial customers that work in the single digits gigabits, right?
Yeah, so Mark mentioned the BK35. We provide simulation models and full test reports of that as well. And actually, one of the most commonly requested is the FX23, the PCIe Gen 3, because just a very popular series. We have a lot of customers asking for us for simulation and models of the performance, and we can provide that as well, and also provide support for that as well.
So, Dave, what's the role of Hirose in addressing innovation, and how do we help our customers in their journey to make their products smarter?
Yeah, so we see the trends. We've been talking about it today, the data, the connections in the systems, and it's really interesting to see, we talk about innovation, such a big word, right? What does that mean? And when we're working with our customers, we're listening to what they're doing today. We're trying to understand how they're using the product, where they're putting the product, what technologies they're going to have coming down the road. Maybe we have to see, they went from, over the last year, they went from a millimeter to half a millimeter. Are they going to need 0.3 millimeter? Are they going to need 0.4 millimeter? Or they're at 56 gig today. They're going to be asking us about 112 soon. we know to ask those questions. We work with the customers. We try to understand the engineering groups where they're trending. We watch for that. We try to design the product to meet not just today's demand, but the demand that's coming down the road, understanding the applications of where they're going to in the future.
Wow, we covered a lot of ground, a lot of markets, a lot of products today. Hopefully our audience finds it very interesting. Thank you, Dave. Thank you, Mark. Thank you, Zili. I'm sure the audience has a lot of questions, so we're going to open for question and answer. Thank you.
Olá, pessoal, estamos de volta, então, aqui ao webinar, onde a gente vai começar agora a sessão de perguntas e respostas. Jorge, tudo bem?
Hi Brasil, how are you? ¿Cómo están los amigos en Brasil? Saludos.
Thank you very much for being here and for the webinar, to host this webinar. And we think we have a lot of questions here. I took notes. And we have also on the chat here. And we're going to invite now Dave for the room. Dave, please turn on your camera and microphone and say hello to Brazil.
Great to meet everybody from Brazil. Great to be here.
Thank you, Dave. I'm going to invite Mark now to say hello to our audience also.
Sauda Cois, or I don't know if that was correct, or Boa tarde.
Thank you very much for being here. Good afternoon. Boa tarde. É isso aí. I'm going to invite Zili Young for the room. Please, Zili, open your camera and microphone and say hello.
Hello, everyone.
Thank you very much. And Rogério, I'm going to ask Rogério to come to the room, turn the camera, say hello.
Hello, Brazil. Hello, everybody.
Thank you very much. Hey, guys, thank you very much for the webinar. It was incredible. And I have here some questions that I took from the chat. People send only to the admin, and I just read it here. But I'm going to start by one question from Eduardo, okay? Eduardo is asking, is there any line that combines data and power on this floating connectors?
Yeah, I think Dave can answer that, and maybe Mark can follow up.
Okay.
Sure. Yeah, absolutely. So the primary product that I was talking about during the session was the FX23 series, and so the FX23 series has data contacts throughout the center of the connector. The FX23 series has power contacts. There are 4 power contacts on the connector, and those 4 contacts have support for 3 amps per contact, and they are located in the 4 corners of the connector. Excuse me, sorry. The option potential is that you could have multiple devices needing power in your system. You can run that power through that while at the same time running PCIe or other high-speed data signals through the middle of the connector.
Mark?
Okay.
You're not listening.
Mark, please turn on your mic.
Sorry, I hit the button and muted instead of unmuting. Sorry. For the micro connectors, we've sort of gone on 2 different paths so far. So our floating connectors do not have dedicated power pins today, but certainly dedicated power pins is a real trend for many of our micro connector families. So it's very likely that in the future we will be combining floating and power. Today, to get additional power over any of our connectors, including our floating micro connectors, the other obvious option is just to gang multiple signal contacts, which each have a rating of maybe 0.3 or 0.5 amps to achieve the total power you may need. So that'd be the best solution we'd offer currently.
Yeah, Mark, but they can use one fixed connector for power and then put a floating for signal, right?
Well, that'd be a way to slice it as well, of course. Yeah, if you just simply broke it out as a separate connector, right?
Yeah, because normally you cannot put two connectors together because of the over constraint. But if one is floating, you can have one dedicated to power, one to floating. Also, regarding the floating connectors, you saw some vertical ones. We also have floating for coplanar and in right angle and other configurations.
Tiago, eu gostaria de fazer uns comentários, pode?
Uhum.
As respostas, né, deles são interessantes. O floating, o conector flutuante, é uma solução para conector placa-placa, né? E o David disse que ele mostrou aqui um modelo, o FX23, né, que tem 4 vias para alimentação que ficam nas extremidades, né, tá? E são 3 amperes, e junto tem sinal. Então, essa característica de flutuante, ela é muito interessante porque ela absorve uma tolerância. Quando eu vou fazer conexão placa a placa, eu consigo absorver essa tolerância. E quando eu tenho vários conectores placa a placa, né, isso se torna um grande desafio. Então, isso facilita o projeto, facilita a montagem, facilita a operação, porque ele aceita uma tolerância, né? Então, tem casos, por exemplo, o BM54 que mostrou aí, tem uma tolerância de mais ou menos 4 milímetros, né? Então, isso é uma coisa fantástica, e a Hirose tem várias opções de conectores flutuantes. Agora, o que o Mark falou é interessante, porque hoje existe uma tendência de misturar sinal com energia, com potência. Em vez de usar 2 conectores separados, a tendência hoje é usar um conector só. É uma forma de eu ganhar espaço na minha placa. Então, eu junto a alimentação, né, vias de alimentação com vias de sinal. E isso salva um espaço tremendo, e a Hirose tem várias opções nesse sentido. Bom?
Thank you, Rogério. Thanks, Eduardo, for the question. I have another question here. I think Dave and George can help me on this question. It's similar to that one. You mentioned that the pitch is smaller and smaller, and considering high power and communication data speeds that's also higher, this is a huge challenge for you guys that designs connector, right? One cannot interfere in the other, right? So this is a characteristics that is really important in your connectors, right?
Certainly. When we look at the physical design of the connector, you think of some of we saw some pictures throughout the webinar where we had power contacts on the outer edges of the connector. This is done deliberately to help get the high power away from the center of the connector, so heat dissipates better. It's easier for the designer for routing traces. The power traces are very wide, and so you tend to need a little bit more space for that. Traditional design, users would use many pins throughout the connector to distribute that power. By using, say, on the FX23, using the guideposts on the corners. Those guideposts are available space, and it makes it very easy to allow for a significant amount of power. And we mentioned 3 amps per contact, and there's 4 of them. So there's plenty of room in the connector today, but we do have to design the connector to support the high-speed data. And you mentioned interference. That can be a concern, and we do take that into account. We have our high-speed team, and they help us a lot with that.
Yeah, I would like to add that it has to do with the choice of materials for the contacts, the choice of material for the plastic, and the design of the terminals themselves. In some cases, we have multiple points of contacts, and heat is generated when there's a high resistance. So by having multiple points of contacts, we reduce the resistance, and therefore we can handle higher current. Our microconnectors can carry, which is even super small, can carry several amps in some cases.
Okay, thank you very much, guys. I have a question here. I think it's for Zili. We run a question, a poll here, asking people if the simulation models and the test reports would help them on the designs. And people say 100% yes. So, Zili, how the simulation models and test designs can help the designers, especially the hardware designers?
Yeah, so for a lot of our SI reports and simulations, not only do they tell you whether a specific speed or standard can support that connector, but also it tells you how much margin you get. So, for example, in the rest of your channel, maybe you can go with a less expensive material because our connector performance is so much better, that gives you a better margin. That's just one example case. We can also provide you the actual data itself, so you can run your own simulations on your own specific channel, because we can't simulate for all the different channels out there for everybody, right? So you can then test it for your own and then see it passes and go with confidence that you can use our connector with no issues.
Okay. Anyone wants to complement? Okay, thank you very much.
I think I'd like to add that there's customers who may not follow the same protocol, but when we provide these test reports for a particular one, that help them guide them in the design. If you are in a project and you can skip a couple of board iterations, that saves you time and money. So we can help you in that development process.
Thank you very much. I have a question here. I think it's for Dave and Rogério. Okay, ZIF is a connector that's it's popular here in Brazil on our designs, and it's used for TFT displays and other applications. And you mentioned that are different ways to connect ZIF connectors, right? This it's good for production and also to the reliability of the product, right, Dave?
Yes, so there's position of the contacts. So we have bottom contact, top contact, and we have versions that are both bottom and top contact. We have vertical entry and the traditional right angle entry. And Mark mentioned some of our One Action series. The One Action series adds to that. So there's a couple of advantages here. So when we're talking contact position, a top and bottom, if you think about routing a flex from one board to another, so let's say it has to curve around and come back in to the connector below it, the contact might be bottom contact on the top board, and it may be top contact on the bottom. And we have products that you could use the same connector on both boards, and it's top on one and bottom on the other. You don't have to change connectors. Makes it easier in manufacturing. We have vertical entry, tight space. I think you were kind of symboling, like if somebody bends that flex, right? If you need to go up quickly or move away, you may have to change the actuator. Let's say a front flipping actuator or a back flip actuator. If you're worried about, let's say the flex is going to bend up away from the connector, then a backflip style is very important in that application. So we have all those options available for our line, and there's an awesome configuration tool right on our website to make it easy to identify speed if your data speed is important, identify the size of the product if that's important, the pitch if you have a tight space. We have products that have 0.5 millimeter pitch, or I should start 1 millimeter pitch, 0.5 millimeter pitch, 0.4 millimeter pitch, 0.3 millimeter pitch, 0.25. And we have actually one of those One Action products I'm a big fan of. The FH62 series is a 0.25 millimeter pitch, but the mount on the PC board is 0.5. That saves you money in the design, and that can be helpful for customers as well.
So
Thank you very much.
I'd like to add, we have a very wide array of solutions.
Yes.
If you are concerned about power, we have SIF connector with dedicated power. If you are concerned about EMI, we have one for shieldings, various pitches and so on. Also, we can help you in the routing. How is the assembly, as they said, how are you going to bend the cable? And finally, in manufacturing, what issues we can help you. We can help you guide the selection so you have fewer issues in the assembly as well.
Thank you very much. I'm going to talk in... Rogério.
O que o Dave falou é bem interessante, o Dave Gallagher e o Jorge, né? Assim, em termos de conector ZIF, a Hirose tem muitas opções, né? Então, entrada vertical, entrada normal, 90 graus, 180 graus, né? Vários pitches, né? Vários espaçamentos, quer dizer, realmente para conector flexível, vai colocar um display ou vai colocar uma placa que tem que virar, né? O conector. Então, realmente, isso é um grande sucesso aqui no Brasil também, na venda desses componentes, com altíssima qualidade. Né? E eu vejo que uma coisa interessante, ele falou do FH62, é uma coisa muito interessante também. O pitch do contato, né, a largura do contato, 0,25 milímetros. Mas para montar na placa, 0,5, né? Então, você pode encontrar com um conector mais estreito e ele vai se adaptar na placa. Então, tem várias e várias opções para se adaptar a diferentes projetos. Tá? Esse realmente é um grande produto da Hirose. A Hirose é líder mundial em conectores ZIF. Tá?
Thanks, Rogério. I'm going to say in English and repeat in Portuguese, okay? Now, people, you can connect with all the engineers here in the Hirose and ask them if you have questions, and mention that you saw the webinar here in Embarcados, they are going to answer you or forward your question to another engineer in Hirose. Am I right, George?
Yeah, we understand that in development you choose a new connector which you may not be familiar with. We are here to help you in the selection, in the design, through the whole journey. So when you reach out in Brazil to our rep, Rogério from ATL, he'll forward to us, and we have a team of engineers across the country who can help you succeed.
Thank you very much. Pessoal, então, Jorge Jimenez, Dave Gallagher, Mark Warren, Zili Liang. Esse é o momento de vocês entrarem no LinkedIn, fazer conexão com eles, que eles podem ajudar no projeto de vocês. E também o Rogério Moreira, que eu tenho certeza que vocês já conhecem por aqui e já participou de outros webinars com a gente também. Conecte com ele também, que ele está aqui no Brasil para auxiliar vocês. There's one last question here from Julio. Julio asked, how many height options are there in the product line that have different heights to connect FPC?
That's for Mark.
Yeah, I could talk about that on the smaller connector, and it sort of apply to some of the larger connectors, I think, that Dave. And the answer is quite a few. We're actually really extending this in some families of products. Though one great example in the smaller medium connector family is our DF40. And if you happen to look that up, I think today you'd find maybe 8 or plus various stack heights available, maybe even more. So, those can go in increments of 0.5 millimeter from 1.5 millimeters today, maybe all the way up to 8 millimeters. Some of the FX23 products, the larger products, also come in maybe, 4, 5, 6 different stack heights. And we're increasing this. So it's hard to give a perfect answer because it's evolving, and we're actually really expanding our height selection across the board on a lot of our products. So I think the best answer would be let us know, let our reps know exactly what dimensions you're looking for, and we can try to help navigate you to what might be some of the best choices to look at.
Thank you, Mark.
And reach to Rogério, and he can set up a little video conference with your engineers to decide what you are trying to do, and we can help you.
Thank you. Rogério?
Eu olhando aqui no datasheet, vai desde a menor 0.5 milímetros até 6,18 milímetros. Tem 2, tem 1, tem 0,7. Então tem muitas opções mesmo. Como eu falei, os conectores FPC é um campeão de vendas da Hirose.
Thank you very much. People, thank you very much for coming here to the webinar at Embarcados. And now I'm going to ask Rogério to say the last words in this webinar for the audience. Please, Rogério.
Ok, muito obrigado pela atenção. Agradecemos aí a oportunidade aqui no Embarcados, também ao time da Hirose aqui presente, a todos que assistiram. Veja que esse seminário trouxe ideias muito interessantes, tendências muito interessantes em conectores. A Hirose está sempre lançando coisas novas, sempre se adaptando, sempre vendo as tendências. Então, é um grande fornecedor para vocês em termos de conectores. Então, estejam à disposição, nós estamos à disposição de todos, né? Gostaria de só retomar também a nossa rede de distribuição, né, que é a Avnet, Futuro, a Highland, que são os distribuidores globais, a Alphatec, a Outcomp, os distribuidores aqui no Brasil, brasileiros, e os de catálogo Mauser, Digiki, New York, representada pela Lateri. Então, existe um amplo canal, existem soluções fantásticas, nós da TL estamos aqui também disponíveis para discutir todas as soluções no seu projeto, tá bom? Um grande abraço a todos, muito obrigado.
Muito obrigado, Rogério. I'm going to ask Mark now to say the last words here in our webinar for the Brazilian audience.
Me? Okay, well, it's been a pleasure to have a chance to meet some people virtually. I certainly hope we get a chance to follow up on some specific requests. And everybody, boa tarde.
Boa tarde, boa tarde. Thank you very much. Carlos Zundo says, thanks everyone for participating in the webinar. So people, you can share also your comments here that we read here online, okay? We are live now, right? Zili, your turn, and now you can give the last words in our webinar for the Brazilian audience.
Yeah, thank you for having us. You were, a great audience. You guys got some really good questions for all of us. And I hope we can follow up with you and help answer whatever problems and solutions that you guys need in the future.
Thank you very much. Thank you very much. Dave, this is your turn to say the last words here in our webinar for Brazil. And we invite you all guys to come to Brazil in an event also to talk in person with the Brazilian guys.
That sounds like fun. I got to put that on the calendar soon. Really appreciate everybody today coming out, spending some time with us, and some great questions. We look forward to helping you out. We love connectors. We're passionate about connectors here, dedicated to connectors at Hirose, and we hope that we can provide you the support you need to identify the right connector for your application. Thank you for having me.
Thank you very much. Jorge, now it's your turn to say the last words in our webinar for the Brazilian audience.
Yeah, I'm so happy to help our friends in Brazil. I was born, I'm from South America. Nothing will make me happier than contribute with technology to our continent. Thank you for having us today.
Thank you very much. And I hope you come to Brazil, all you guys, and share knowledge with the engineers in our area here. We are here to promote designs, new designs, and thinking about the future of technology. Thank you very much, guys. I'm going to ask you now for you to turn off your cameras and turn off your mic, and I'm going to finish the webinar. Pessoal, muito obrigado, tá, por participarem do webinar ao vivo aqui no Embarcados. Nós fizemos essa apresentação hoje em inglês, aí teve a sessão de perguntas e respostas em inglês também, tá bom? Vocês podem deixar os comentários aqui, que eu vou ler todos eles. A Valéria disse para entrar em contato com ela, da TL, se vocês tiverem aí alguma demanda, se conectem aos profissionais que estiveram aqui hoje, tá? A gente parou a engenharia lá da Hirose para trazer os especialistas aqui ao vivo. Vocês viram aí que a gente planejou tudo isso e fizemos essas sessão de perguntas e respostas. Esperamos vocês para os próximos webinars. Nós temos muitos conteúdos técnicos aqui para vocês, tá? Então, esse é o momento de se conectar. O link de cada um dos apresentadores está aqui no chat. Então, se conecte a eles. Se você estiver vendo o replay, né, procure o nome deles no LinkedIn e se conecte lá e eles atenderão vocês. O Samuel disse o seguinte: obrigado pelo webinar. Muito bom, boa tarde para todo mundo. É isso aí, pessoal, muito obrigado então pelo tempo de vocês. Vou encerrar o webinar agora. O replay ficará disponível para quem fez inscrição, né, no mesmo link. Então vocês já sabem aí, né, vocês podem contar também com o replay. A Rosileia gostou também, deixou o seu comentário aqui, então só registrando aqui para vocês também. Obrigado, boa tarde para vocês. And thank you very much for the guys that were here from the engineering of Hirose. Thank you very much. Obrigado, pessoal.